This is part 4 of our Chapter 2 chemistry lecture. There we go. We learned that water has many important chemical properties due to the fact that it forms polar covalent bonds. That the water molecule is formed by polar covalent bonds between oxygen and hydrogen, and that individual water molecules are attracted to each other by hydrogen bonding. And so this leads to the fact that water is the most important substance in the body. And it's the, the substance with the highest percentage in the body as well. There are three general properties that water possesses that make it important in the body. First, it's an essential reactant in the chemical reactions of living things. Do you remember which reactions use water to split apart a molecule? Remember, they were called decomposition reactions or catabolic reactions. Another word that you might see is hydrolysis, using water to break down a molecule into smaller substances. Water has a very high heat capacity. That means it takes a lot more energy or a lot more time to heat water than it does to heat something like, for example, if you go to the beach, it takes a really short time for the sand to get hot. It takes a longer time for the water to get hot during the day by the heat of the sun. um, and vice versa. In the evening, the sand is warmer because um, I'm sorry, the sand is cooler because it takes the sand less time to cool when the sun goes down, and the water still feels kind of warm because it hasn't had enough time for the temperature to drop yet. So water has a very high resistance to changing in temperature. Water is an excellent solvent. In fact, we call it the universal solvent because it can dissolve so many different chemicals. The chemical reactions in our bodies take place in water. That's one reason we need so much water, is for all these chemical reactions, all these catabolic and anabolic and exchange reactions. Um, they take place in water. They don't take place in air, for example. They take place in water. Um, Water molecules actually participate in dehydration synthesis reactions, which releases water molecules, and hydrolysis reactions, which use water molecules as one of the reactants. Water's high heat capacity means that it has a high ability to absorb or retain heat, and that characteristic enables us to maintain a fairly constant body temperature. Um, Temperature depends directly on the kinetic energy or the random energy of molecules. Since the water molecules are linked by hydrogen bonding, an increase in temperature requires breaking the hydrogen bonding, followed by increasing the movement of the molecules. And that takes a lot more time than it does for other substances like metals or sand, like we talked about before. Aqueous solutions are solutions that consist of a fluid solvent, most often it is water, and dissolved solutes like table salt, NaCl. Whenever salt, sodium chloride, dissolves in water, we call that either dissociation or ionization. And that's when an ionic compound breaks apart into its individual ions in water. And those types of substances, we call those electrolytes. The substances that we drink Gatorade or we give our children Pedialyte, these are drinks that contain not only water but also electrolytes that we can lose when we exercise and sweat. Um, and then down at the bottom, an organic molecule can also be soluble in water. It can also be a solute if the organic molecule contains polar covalent bonds. So we know that glucose is a sugar, and sugar is also soluble in water. So what are the chemical properties of water that make life possible? Water forms by polar covalent bonding, and then water is held together. The molecules of water are attracted to each other because of hydrogen bonding. And what does this lead to? This leads to water having a high surface tension, water having a high heat capacity, water being a good solvent. Um, Why does water resist changes in temperature? Because it has a high heat capacity, because of the fact that in order to change the temperature, you must break the hydrogen bonding and then cause the individual water molecules to move faster. Okay, pH. pH is the level of, if it's a low pH, it means that um, the solution is more acidic. And if it's a high pH, the solution is more basic or alkaline. Hydrogen atoms, when they lose their electron, become hydrogen ions. Hydrogen ions are very reactive, and the concentration of hydrogen ions in the body is measured as pH. So a high concentration of hydrogen atoms means a low pH, means acidic. The higher the concentration of hydrogen ions, the lower the pH, the more acidic the substance is. If the solution's pH is 7, we say that it is neutral. If it's below 7, it is acidic and it has a high concentration of hydrogen ions. And if it is above 7, it is basic, or we can also call it alkaline, and it would have a lower concentration of hydrogen ions. When we go down 1 pH unit, that's a 10-fold change in hydrogen ion concentration. So if I have a solution that's pH 3 and it changes to pH 2, then that means it has increased its hydrogen ion concentration by 10 times. This is how you write hydrogen ion concentration. It's increased hydrogen ion concentration 10 times. And if you go down to pH 1, it would be 100 times, and then pH 0 would be 1,000 times, and so on. That's how it works. Here are some common solutions, common substances, and their pH values. Very basic pH would be a lot of your cleaners like ammonia, and oven cleaner. These are very basic, extremely high pHs. Blood is basic, but it's still very close to neutral. Pure water is neutral. Urine varies between being acidic to slightly basic. It kind of depends on the composition of your urine. And stomach acid or hydrochloric acid is extremely acidic, so it has a low pH. Define pH. pH is the measurement of the hydrogen ion concentration in a solution. If the pH is low, the solution is acidic, and if the pH is high, it is alkaline or basic. An extreme change in the pH of body fluids is undesirable because it can cause our cells to break down, it can cause our proteins to denature, our enzymes can denature, and that can lead to death, sickness and death. All right, if a substance releases hydrogen ions, it is called an acid. Because a hydrogen ion is actually the same thing as a single proton, because that's the only subatomic particle in a hydrogen ion is a single proton, then often we call acids proton donors. A strong acid dissociates completely in solution, so hydrochloric acid dissociates completely into hydrogen ions and chloride ions in water when dissolved in water. If it removes hydrogen ions from solution, it is called a base. Sometimes bases will release hydroxide ions, and they're called bases also. A very strong base that's a very common base found in Drano to clean our drains with. It's also found in lye soap is sodium hydroxide. And sodium hydroxide is a base because when it dissociates in water, it dissociates into sodium ion and hydroxide ion. And releasing hydroxide ions in solution also makes it a base. Either removing hydrogen ions or releasing hydroxide ions makes a substance a base. Weak acids and weak bases just do not dissociate as completely as strong acids and bases. And they are important in maintaining pH balance in the body. Weak bases counteract when we exercise and our muscles begin producing lactic acid. Weak bases will counteract that so that our body fluids don't drop too low. And then we've got chemicals called salt. Salt is not always sodium chloride. This is only one type of salt. A salt is composed of a cation, any cation besides hydrogen, and an anion, any anion besides hydroxide. So you can have potassium chloride, you can have magnesium bromide, because all of these, the first ion is a positive ion or a cation, and then the second one in the formula is an anion or a negative ion. So these are our different salts as well. Electrolytes are substances that can dissociate in solution and conduct an electrical current. You may already know that salts can do that. Sodium chloride in water will conduct an electrical current. You may have made a homemade battery before and found out that sodium chloride in water can conduct an electrical current. Some examples of ions that are released that we call electrolytes are sodium, potassium, calcium, chloride ions, and bicarbonate ions. These are important electrolytes in the body. Now, since the pH in the body needs to be maintained at around, except for in areas like the stomach, which has a very low pH, our body fluids typically need to remain within 7.35 and 7.45 pH, which is slightly basic, very close to neutral. So there are compounds, chemicals, that will help to stabilize pH. When the pH goes too low, then it will remove hydrogen ions from the solution, so the pH will raise back up. And then when the pH goes too high, it will add hydrogen ions to solution so that it will lower the pH. One example is antacids. We take antacids like Tums and Rolaids and Nexium because they bind excess hydrogen ions and remove them from the stomach, and they raise the pH of the stomach acids. An acid releases hydrogen ions in solution, a base removes hydrogen ions, and a salt is a combination of a cation and an anion as long as they are not hydrogen or hydroxide. An antacid decreases stomach discomfort by raising the pH. Now we're going to talk about the four macromolecules. Carbohydrates are a combination of carbon, hydrogen, and oxygen in a ratio close to 1 to 2 to 1. Glucose has 6 carbons, 12 hydrogens, and 6 oxygens.